Hello and welcome, everyone. My name is Martin, and this is the Blueprint Podcast brought to you by Bench. At the Blueprint Podcast, we talk about how AI will impact engineering teams and how it is doing so already. Our goal is to democratize practical AI knowledge to enable ambitious teams to thrive in this new paradigm. Today, my guest is Moritz, a program manager at DeltaVision and a previous director of engineering at Hyperganic. Moritz, how are you doing today?
Hi, Martin. Nice to be on your podcast. Also, happy to be one of your first guests on the podcast. Quite an honor.
It's a privilege to have you on. Thanks so much for joining us and believing in us that early. Awesome. Moritz, let's start very broadly. Do you want to talk about your current role at DeltaVision very briefly, what you're doing, and kind of how maybe you're touching AI already in the role?
All right, sure. So, first of all, short introduction. My name is Moritz. Thanks, Martin. You kind of already touched base on the highlights a little bit. I was previously director of engineering at Hyperganic, which was a generative design AI for engineering type of software company. I think we're going to go more into the positioning of that a little bit later, probably. So I'll move on to DeltaVision. I recently joined DeltaVision about a year ago now. Started as a project manager, now recently got promoted program manager at DeltaVision. DeltaVision is a new space deep tech company from Munich. We're supplying critical fluidic systems for both rocket propulsion, space propulsion. That equipment includes everything from, valves, pumps, fluidic equipment on a wider scale. So we are effectively rolling out horizontally. So we have quite a large portfolio of different type of fluidic equipments that we are selling off the shelf. Hereby, there's a differentiation to be made between high customization parts. So effectively, we allow customers to co-develop with us certain equipments. So we would have a large area of customization or configuration, how you would call it in the space industry, where we would customize the parts to fit into their respective systems. And then there's the other part where people do less customization, so smaller configuration changes, but therefore we are scaling up more the production. So it's more a serial production thought, which is quite novel in the space industry, I gotta say. So also space industry is moving a lot into the types of production processes, and as we have seen it previously in automotive. And then besides that, we're moving up the vertical to also start integrating systems. So providing services effectively for our customers to integrate systems for them, and with the ultimate goal to be a key player enabling orbital refueling, orbital services, and so on. So there's a lot of very exciting activities happening at the same time. We're rapidly growing, and maybe at that point quickly positioning also, if someone listening to this is willing to step into aerospace, then we are hiring as well.
Love that. Awesome. I remember you told me that you guys have seen a lot of headcount growth. So glad this year growing further. Awesome. Moritz, let's jump into the general topic of AI and engineering. I would love to hear your general thoughts about AI and engineering in its current state. What have you seen?
Yeah.
Of course, it's a huge question. We're going to dive deeper as we go. But what's your general current feeling and thoughts on this space?
It's definitely an exciting space. It's like you already said, it's a wide question. Let me think where to start. So I think there are a few trends. I'm trying to stay as pragmatic as possible. I'm not really a big fan of hyping certain topics too much. What I think AI is best at is effectively breaking silos. So in effectively democratizing knowledge that maybe sits downstream or sits in silos that cannot really be tapped into by engineers at any place in the value chain, really. So let me maybe give an example to illustrate a little bit what I think the key strength is, and then maybe we can try to adapt that level of thinking to the other types of tasks that AI, in my opinion, is good at. Let's put yourself into the shoes of someone that sits at early design, and it really needs to evaluate many options available to the person, and effectively computational tools already in the era of only topology optimization. We're effectively aiming to democratize the knowledge of simulation engineers, detailed design engineers, manufacturing engineers, to the person sitting all the way in the front, for example, to enable them to maybe take better decision, not the best decision. You will probably never be in a place where you take a design choice that is 100% the correct one, but you might be, let's say, at 85% of whatever your measure of success is. And I think that shift is really accelerating through AI now. So we see that complex simulations are getting easier. We see that, and this is also an area where I see you guys playing a lot, democratizing the entrance to engineering a lot. So making it easier for people to at all start working with these engineering tools by, for example, unifying effectively the interface that engineers see, right? Because a lot of it is also AI helps you to break the silo of effectively how to use a certain tool. If you compare it to a chatbot, everybody sees that with ChatGPT, for example, or Claude AI or Gemini, or you name it, right? They effectively all have the same user experience, even though whatever happens in the background is quite different. So long answer short, I think the praise of AI in engineering is first and foremost to break silos, and by that to enable all sorts of other types of secondary effects like being faster to market and so on. Yeah.
That's quite interesting you mentioned that, because I feel like the breaking of the silos kind of topic has been a topic in engineering for a long time already. I feel like many different softwares or companies have tried to make the claim that we're going to break down silos. There's different approaches, right? There's approaches like the AI approach that you mentioned, where sharing knowledge maybe across departments becomes easier. But there's also all the design review softwares. And I feel like this buzzword, I'm going to call it, has still kind of stayed a topic. And maybe it's indicative that the problem has not been solved with the previous generation of softwares. Why do you think AI is different? Why do you think that AI will be the final kind of let's say push that solves this issue, and maybe this kind of stops being such a big topic in engineering?
Oh, there's a lot. This is a loaded question. I'll try to break it down a little bit in complexity. I'm not sure if I can answer all aspects of this. One aspect that I do see where I think AI is a new tool that enables maybe solving of certain problems that weren't solvable before is just strictly the user experience and effectively the human machine interface, where previously you would need to follow a quite rigid set of instructions in order to get any tool to do anything. And that required quite a lot of experience. So you would need to really understand how this tool works, what the mechanisms were, what the failure modes and so on were, in order to make sure that whatever comes out of the software is as close to reality as possible. Because in the end of the day, engineers try to build physical products. We're trying to really improve the world, at least mechanical engineers. And so you need to have a very good understanding of what your final product is. And you also need to have a very good understanding of how to make your software, whatever you're using, do the thing you want in order to arrive at your set goal, which is whatever, producing a bracket, producing an airplane, producing a car, whatever. And now coming to the part that is novel now about AI in particular, or with the event of transformers, is that effectively these models somehow do understand natural language, and they do understand incomplete, or they can somehow infer the meaning of incomplete instructions. So let's say everybody knows that practically from working with ChatGPT, you just give very short instructions, and somehow it still does produce some meaningful output. Of course, the more precise your prompt is, the better your output is going to become. So effectively, you're still again approaching the complex instruction set as it was before to be very precise in certain things. But you have the assistance, and there's some sort of a translation layer between the human language to machine language in a way, which was a tedious learning process over the years. I'm not saying that the AI models we have right now might be the end of the story and the best models we will ever have for the tasks at hand, because they do hallucinate, they do forget information and so on. But it's better than just having to write a very precise instruction set, or even having to physically click on certain buttons in order to achieve a certain design intent.
Yeah, the inference topic I think is very, very interesting. I think it's both an opportunity and a risk, right? Because of course, the opportunities that we get to under-specify sometimes still get a good result, but the risk, of course, is in engineering we don't want anybody to be doing the work for us. We want to know what's happening. We don't want this to be a black box. We want to have this to be an observable process basically. So I think managing that trade-off is going to be quite important in gaining engineers trust, because otherwise, if engineers feel like they're out of the loop, and if they feel like they don't know what's happening, they will kind of probably struggle to feel comfortable to sign off on a design that they supposedly designed, but they don't know how it got to be designed exactly.
Also, one thing you mentioned right now is the risk management. I think depending on the industry you're in, risk management can be more or less of a topic. I can say that in space industry, risk management is a huge topic. So if you don't really understand what exactly it is that you're proposing, your customers you will not be successful with your customers. In fact, you won't be successful, period. There's actually not much to be added. The point is, I can say for aerospace industry, you go through various rounds of a tendering process. So if you want to apply for a new project, for example, and you would need to already have digested a set of requirements very well, and understood that set of requirements very well, and propose a design based on these requirements. And your customer already, of course, has their expertise in that field as well. So they would also challenge the assumptions that you're taking. So even more so, it's important that the ownership about the design that's been made still sits with the person that is effectively defending the ownership. It's, I mean, looking at a potential future scenario, who knows if that ever occurs, of agentic AI producing sort of physical products. If that happens, I'd be quite curious how this, let's say, somewhat rigid process of design verifications and so on would evolve as well. Because I think it needs to evolve on all fronts at the same time in order to really go into a fully AI enhanced engineering future.
I think it's a very interesting prediction to attempt, is when do we get our first AI signed off engineering design?
Yeah.
Let's say in aerospace. I cannot make that prediction right now. I don't think it's soon. I think for the foreseeable future, it's humans being augmented by AI and doing the work faster, but them still signing off on what the AI proposed or what AI participated in designing. I'd love to segue this conversation into your blog. I think that's quite a natural progression here. You write a very interesting blog on a range of topics broadly centered around engineering, and kind of the post I'm thinking about here is the one about AI and engineering design. And you've got a very interesting market map over there, and you had a number of findings from your research. Uh, I'd love to dig in deeper here. What have you found? What have you seen in the market? What's the promising I guess trends? What's the trends where you think maybe they're not exactly the right direction? Again, gonna leave this open to you.
Trends. I'm trying to again stay grounded a little bit. I'm probably not the best person to predict the future. I can, however, it's the same with like looking at the stock market, right? It's always, you always have a feeling, but if the feeling plays out or not is a different topic. What I can say is I have looked at various different companies, and I can see that there are clusters of companies in certain areas. Maybe to start with the motivation of the blog at all. Effectively, this whole blog came together when I decided to leave Hyperganic, to expose myself to more hardware, to say, really not only looking at the virtual part of the product, but actually looking at how is this product being made, how is it being brought to market, to effectively close the loop for my understanding as well. Because in the end of the day, the physical products are the ones that really shape the reality that we're in. So the idea behind the blog was to not forget everything that I've learned throughout the 4 years at Hyperganic, and kind of learn more and teach also more about this emerging field of AI, because there's a lot of hype in the field, and at the same time this can lead to lead to very wrong expectations, and systematically is going to hinder the industry of picking off. So that's effectively the motivation is just to give a uniform platform for people to educate themselves, or to share the little bit of knowledge that I can share. About the things that I found. So it's I can say that there are definitely a few clusters that are emerging. One very prominent cluster, and of course these clusters are evolving. So every time I refresh the article, actually I start seeing new clusters as well. Just to mention that. So to come to the clusters, maybe the most prominent clusters are in generative design / design automation, and the other big cluster is in the field of physics simulation. And I think that the reason, maybe there's a third big cluster in data management, integration, process automation, platforms, these types of tools. So overall, I think there are 4 big prominent clusters when it comes to the engineering design software by itself. Of course, there's also knowledge management. I'm just omitting this entire other field right now. So maybe let's start with the simulation topic. It really does make sense to start there, because simulation is really needed in so many different areas if you want to avoid building physical products to test them, to then just realize, oh yeah, I was actually completely in the wrong path. So this is the emergence of simulation already right there. And now with the physics informed or data driven physics models, like for example SimScale uses them, or NTOP uses them, or many other tools, 1000 Kelvin in the field of process simulation and so on. They effectively use simulation surrogates, so replacements to real simulation, to accelerate optimization loops, or to in general accelerate simulations of product part families. And that really enables engineers, especially in the early design field, to move much faster and evaluate much wider design spaces. And already at that point, if we are looking at design spaces, we can see that there's a bunch of companies in the field of generative design, which is overlapping with the simulation domain, because generative design effectively is the early design part, but it can be, of course, also closer to manufacturing processes like 3D printing, for example, where effectively the generatively designed component can be directly manufactured, at least in theory. And so here, again, we're talking about the early design intersection to the detailed design intersection. And then lastly, we have the last two buckets, which are this more text-to-CAD interface. So effectively, I clustered it under the conceive bucket and early design bucket, where companies like yourself, like Zoo, like NeoCAD, would enable engineers to move much faster into the field of engineering. So you give them the tools to start with a low entry barrier. Effectively, you're democratizing the engineering design, or even everything else that is tied into the tools to engineers. And then finally, of course, you have platforms that potentially link everything together. I think Senera Toolkit, they are quite prominent for the non-engineering audience. N8N is a huge AI, is huge in agentic AI, where you build pipelines effectively. You concatenate nodes in a grasshopper, Rhino grasshopper type of style. I'm personally quite a big fan of Rhino grasshopper, because it's been around for a long time, and it's been super powerful and giving people access to all sorts of tools. But of course, it's quite raw in comparison.
It's interesting to see how this plays out, and kind of what is the dominant interface that becomes the status quo, I guess, in AI engineering, kind of the AI engineering kind of field. Currently, it seems to be text, or kind of those kind of workflow interfaces like Sonera or N8N. But I wonder where we end up. I don't think a chatbot is the optimal interface, but I don't think I don't think anybody really knows yet what it will be, because the field is so new still. On the topic of kind of all these softwares you mentioned, and all the buckets, the kind of the four buckets that you pointed out, I would love to get your thoughts on how do you think the adoption of these will play out in corporates or larger engineering companies? Because what we're saying is, it's decently easy to go into a small engineering company, like a 5 to 10% engineering company, ask them to adopt a new software. But of course, if you go to a huge 10,000 plus person company, like an OEM on automotive, for example, that's a completely different story. So I wanted to get your thoughts on, kind of maybe through the lens of your time at Hyperganic, of how do you see this adoption playing out? What do you think? How do you think that the process will play out on a macro scale? But also, what do you think the main blockers and, I guess, pushbacks almost from the corporates or the larger companies will be to adopting new, let's say, design automation software?
I think this is a very difficult question in the sense that it'll depend majorly on the type of solution that you're bringing to market. In Hyperganic's case, we were bringing a lot of different types of tools to market, very tailored towards solving very specific specific pain points with our customers. But at the same time, we also were building a, let's say, larger SaaS product that would where this question would be quite relevant. So I think the fundamentals really is to understand your customers and understand very well what actually the pain points are that they have. In any event, the thing that you would want to do is to really map out exactly what problems are these people facing and why are they facing it. And as soon as you start to understand where the real pain points are, then I think there are many different ways of bringing your software to market. I'll roughly cluster them into, let's say, 2 buckets now, or maybe 3 buckets. So you have software that is effectively a closed system that attempts to replace existing tool chains into one monolithic type of tool chain, or in this case, one tool. I think Fusion 360 is attempting that. I think Siemens and X, even more prominent, is attempting that. The 3D Experience Suite is attempting that. So they try to build one monolithic block of softwares that links all of the tools together, so you have one consistent product lifecycle management data stream, so to say. I'm not saying that all of these attempts are very, very successful. Some are better, some are worse, but I'll just leave it at that. Then, of course, you have novel types of design approaches in that field. Like, for example, Entop would approach the market with their implicit modeling software, which is definitely more robust than the traditional kernels. It can do all sorts of things that other kernels would not be able to do, just because of the implicit representation of the geometry inside in its kernel. But then there's an interoperability barrier, so to say. So there are effectively conversions from implicits to BREPs, for example, to meshes and so on, because you need to go in and out of this implicit world. And I think in Hyperganic's time, we were exactly positioned at the same place, just with a different architecture in the background. So people would need to go into Hyperganic world and need to go out of Hyperganic world to kind of fit into their PLM. So one very powerful strategy that people are taking is to be interoperable first and then start building out the value. So you start to replace a small little bit in the value chain, and then you grow from there.
So from a perspective of an engineering leader in your current role in DeltaVision, would you say that if the software has a very focused, niche but valuable, let's say, use case, that makes it easier for you to make the case to adopt it?
Maybe to come back to what I'm currently driving together with my little small AI team in DeltaVision. We are attempting to make data evaluation for testing much quicker, and documentation handling much quicker, because effectively before it used to take a lot of time, and I had the pleasure to do it once by myself by hand, and I was like, how do you even do that without like computational tools? It's just such a pain to deal with all sorts of different modalities of data, time series, documentation, Excel tables, you name it, a lot of different inputs. It's like it's so simple to automate this, and effectively I started on the hypothesis that if I find a tool that makes this task or executes this task better than anything else, then the team would also likely adopt this new way of doing things. And I hired a developer, and with the event of vibe coding, you can actually get an MVP out very fast and see if people would adopt it, and iterate your product definition very early. But then we actually solve the issue now. So we completely replaced the 3 different tools you had to use to solve this one single problem, and solve it within one little tool. And now, looking in the future, we're bringing in all sorts of new digital tools, like an MES tool, and we're now thinking about how to interoperate with these tools in order to continue to solve this problem. So again, long answer short, I think it's especially for small lean startups, I think it's very essential to focus on the core value and be the best at it. and then start moving out from there.
Awesome. We are slowly running out of time. So the very last question I wanted to ask you is again about DeltaVision. And potentially it's what you just said, but I wanted to ask about essentially your kind of most painful workflow. So essentially, if you had a magic wand to automate any process in your design or whatever development process, what would you want to automate? What would you like your engineers not to have to do manually?
If there's one thing that I think I do not want anyone to do, then it's copy and pasting data between tools. And I think it has quite significant implications to companies, because many companies, in my opinion, do not yet. They weren't built in a time where digitalization was such a big topic. So enabling data consistency seems to be a winning ingredient, especially in the space domain. If you look at the large space companies like Stoke Space or SpaceX, they have their own self in-house built tools to keep all data consistent within one system and manage it inside there. And that infrastructure choice seems to really enable these companies to move much quicker because they have availability of data. And based on that decision, they can really start to build all sorts of application layer tools on top of it that may or may not be AI enabled.
For the data consistency, just so we understand the point correctly, would you mean, for example, converting all Siemens NX files to CATIA files, kind of being kind of consistent in terms of like CAD file types?
I mean, what you're talking about right now is conversions. I think that can be an issue, but I'm even referring to the entire value chain. To have availability of data all the way from someone configuring a product on your website all the way down to I see a sensor on a machine indicating something and really building up this digital twin, so to say. And along the way, there are so many tasks and challenges along that need to be addressed. Like, for example, the file conversions that you were talking about, then in general, data handling. And I mean, with your product, for example, you're positioned in at least the way I understand it is you're positioned in this interface layer between, the human and the machine, but at the same time, it's also some sort of a platform game. So you're kind of enabling data consistency inherently. And I think that is a real value add because you are allowing people to use multiple tools within one user experience, so to say. And that alone already in still smaller scale than the entire company enables a certain group of people to move faster, which is already a good value add, I think.
So it's almost essentially to make use of the data has to be available and usable. And it sounds simple probably, but that's essentially what you're saying, if I'm getting it right. Awesome. Moritz, we're out of time now. Thank you so much for your time. This was very, very insightful, and I hope our listeners think so as well.
Yeah, sure. Yeah, first of all, thanks for the invite to the podcast. It's been an interesting conversation, good questions. I really enjoyed this to close off my 2025, a year of changes, to be fair. And yeah, I mean, 2 shout outs. First of all, if you're looking to enter the space industry in Europe, DeltaVision is hiring, so feel free to reach out. And of course, also reach out if you've any comments about my articles. They're constantly evolving. Like I said, the only constant is change, especially this year. So yeah, that's it. Thanks, Martin.
Thanks so much, Moritz, and have a great rest of your day.